For the last, what, decade now, if you've been paying any attention to the AI world, the mantra was so simple: data is the new oil.
It was powerful, and we all bought into it.
We all bought into it. The idea was that the scaling laws were, basically inviolable. Just feed the machine more data, add more compute, and performance would just get better. It made perfect sense, didn't it?
It did. The mission was clear.
Mm.
Just drill into the internet,
Yeah.
refine that crude info, and intelligence would just emerge.
Right.
And that narrative, I mean, it powered the entire revolution we've seen. It held true for a remarkably long time. But now that the models are getting truly gargantuan, as we target the next generation of frontier models, that simple logic is crashing headfirst into a very hard, very uncomfortable reality.
And that's the real data dilemma.
That's it. Exactly. The question is no longer just how much data we can vacuum up, but whether the data that's even left is it clean enough? Is it diverse enough? Is it even conceptually good enough to get us where we need to go?
So today, we're doing a deep dive into why we're staring down this data cliff, which is happening way faster than anyone really predicted. We're going to cover the simple quantity crisis, the exponential hunger of these systems.
Then the hidden costs, the labor, the legal battles.
Exactly. And finally, we'll get into the fundamental conceptual failures of the data sets we've relied on for so long. All right, so let's start with just the sheer appetite. When you look at modern LLMs, they aren't just learners. They are voracious consumers.
That's a good way to put it. We are talking about models that have scraped and just consumed petabytes of data. I mean, that's a huge, probably unsustainable chunk of the public internet.
It feels like an exponential problem meeting a linear solution.
But that's the core tension, right? The demand for data is shooting up exponentially because the models are getting bigger, and we want them to be better, more nuanced.
Yeah.
But the supply of high-quality human-generated data, the original stuff.
It's growing linearly, at best.
At best. And in some areas, it might actually be slowing down. You've used up all the UZ stuff.
And used up is the perfect term here, especially when you hear researchers talk about the token crisis.
Absolutely. So think of a token as just a word or a piece of word. When the Epoch AI research group crunched the numbers on this, they came back with a profoundly worrying prediction.
Which was?
That we could run out of high-quality public text data as early as 2026.
2026, that is right around the corner.
It's not far off. The well isn't completely dry, but the really pure, easy-to-get water is gone. We've already systematically consumed Wikipedia, Project Gutenberg, huge archives of academic papers, Reddit's entire history, and most of the big news sites.
It really is like we found oil just sitting on the surface, scooped it all up, and now we realize we have to dig thousands of feet down for the contaminated dregs.
Yeah, that's a great analogy. The internet is still vast, but that vastness is deceptive once you apply a quality filter, isn't it?
It has to shrink the usable pool dramatically.
Oh, it does. The internet is mostly noise. It's SEO spam, it's a broken code, it's endless duplicates of the same article with one word changed, incoherent forum posts.
Right.
And if you feed that raw, noisy data into a model, you don't make it smarter. You hit diminishing returns fast. And worse, you actually start to see model degradation.
Okay, so if you push too much of that low-quality sludge into the learning pipeline, what actually happens to the AI's capability?
The output just suffers. It starts to struggle with complex reasoning, it loses its grip on subtle context, and this is the big one, it dramatically increases its tendency to hallucinate.
So it starts making stuff up, but more confidently.
Exactly, confidently generating falsehoods. And that's why the quality filter is just non-negotiable. You could have 1 trillion low-quality tokens, but they will never equal the learning power of 1 billion tokens of clean, well-structured, human-edited writing.
Which takes us right to the next big point. There's this common, almost naive idea that AI just magically reads the internet.
Yeah, and that's just not how it works.
The reality is that raw data from the wild is, it's toxic. It's chaotic.
Yeah.
And the process of turning that chaos into a clean, usable data set is one of the biggest, most expensive engineering challenges in the entire industry.
And the era of free scraping, the sort of data Wild West, it's over. It's definitively over. We are now in a massive acquisition battleground. The legal and the monetary hurdles are just skyrocketing.
You see it first with what people are calling the walled gardens. For years, these platforms, Reddit, X, Stack Overflow, They benefited from user-generated content.
Free content.
Right. But as soon as the AI giants came knocking, they realized they were giving away the core resource of the new economy for free.
Exactly. They realized, we have to host this, maintain it, moderate it, and the AI industry was just monetizing their free labor. So they shut down the free or cheap API access. Now, if you want to train on that content, which you need for modern conversation,
Yeah, I'll have to pay.
you have to pay millions, sometimes tens of millions of dollars for the privilege. That single move has totally changed who can even afford to train a large model.
And if the money wasn't a big enough hurdle, the legal landscape is just crumbling. We can't talk about acquiring data without getting into the intellectual property nightmare.
It's a huge shift. You're seeing these massive copyright lawsuits, like the New York Times suing OpenAI or artists going after Midjourney.
So the whole legal framework is in question.
It is, and these lawsuits point to a future where data licensing might just become mandatory for everything. And if companies have to license every single token they use, the cost to train a model will go beyond anything we can even imagine today. It's an existential risk for any smaller player.
And even after you've paid millions to get the data, the cleaning process itself is an absolute engineering nightmare, right? This is way more than just removing broken links. You've got, what, 3 huge challenges right off the bat?
At least. The first one is deduplication. If you train a model on the same piece of text or code over and over again, which happens all the time when scraping the web,
It doesn't learn, it just memorizes.
it memorizes. It doesn't generalize the concept.
And that's what we call overfitting, right? Where the model is basically useless for anything new.
Precisely. It loses that ability to think abstractly. Second, there's PII removal scribbing. Personally identifiable information, names, phone numbers, addresses, social security numbers, all of it has to be rigorously filtered.
Which must be a massive privacy compliance hurdle.
It's huge. One mistake could lead to a catastrophic data leak and massive lawsuits. And that requires really complex, multi-layered technical systems running all the time.
And the third one, toxic content filtering. I mean, given what some parts of the internet are like, that has to be a constant draining battle.
It's essential but relentless. If you don't filter rigorously, your model will just absorb and then spew out all the bias, the hate speech, the dangerous junk from the darker corners of the web. And this isn't just an engineering problem. It requires constant human oversight.
And that brings us to the biggest irony in this entire situation, our reliance on human labor. We're trying to build machines that automate thinking, but we need humans to teach them what good thinking even looks like. Let's talk about RLHF reinforcement learning from human feedback.
Yeah, RLHF is a core process. The models don't just know what's helpful or safe. They have to be taught. And they're taught by humans who spend hours ranking thousands of AI responses. Was this answer good? Was it respectful? Was it accurate?
And that creates a couple of major problems.
It's two, really. The first is subjectivity. The biases, the cultural leanings, the ethics of those human labelers, they get baked right into the model. They become the model's biases.
But isn't some of that unavoidable? If you're training for safety, you're already imposing some kind of ethical framework, aren't you?
That is the essential difficult tension. You have to impose some framework. But the second problem is maybe even more critical for the future. Expertise scarcity.
Yeah.
You're moving way beyond the point where, average low-paid workers can do this labeling.
Because the questions are getting more complex.
Exactly. If you want a model that can analyze a legal document or help diagnose cancer or validate complex code, you need data that's been labeled by actual lawyers, doctors, or senior engineers.
That sounds incredibly expensive.
It is. That kind of labor is scarce, it commands a high salary, and it creates a hard financial and logistical ceiling on how advanced these next-gen models can even get. It's a human bottleneck on progress.
Okay, so let's shift from the problems of how much data and how to clean it and move to the fundamental conceptual problems. Because even if we had a magic wand and all the data was pristine and abundant, we're still left with limits in the source material itself. It's the old saying, right? The map is not the territory.
And this challenge is systemic. It's arguably the hardest one to fix. One of the most worrying issues that's emerging is something called the Ouroboros effect, or model collapse.
Which sounds like a snake eating its own tail, a kind of a never-ending cyclical problem. How does that play out in the data?
It's a terrifying feedback loop that's already happening. As AI becomes more common, the internet is just flooding with AI-generated content.
Right. Blog posts, articles, comments.
All of it. So future models, when they go to scrape the web for new data, inevitably start ingesting content that was made by previous AI generations.
Yes,
So it's like making a photocopy of a photocopy of a photocopy.
you just lose all the original detail.
Exactly. The signal degrades. The models start to lose the nuanced, creative, weird edge cases of human expression, the specialized vocabulary, the complex grammar that signals real human insight. Eventually, the data all converges on this bland, homogenized average, and the models become less creative and more repetitive.
And on top of that blandness, there's the huge problem of cultural bias in the source data itself, which gets summed up by that acronym, WEIRD.
Right? WEIRD stands for Western, Educated, Industrialized, Rich, and Democratic. The vast, vast majority of the foundational training data, especially the really clean stuff, comes from this cultural context. English dominates the data sets,
By how much?
often by a factor of 10 or more compared to the next most common language. So what you get is an AI that's profoundly skilled at reasoning, but only within a very specific, very narrow cultural lens.
Which means non-Western philosophies, diverse dialects, nuances from the global south.
They're all profoundly underrepresented or just missing entirely. And this is a crucial limitation. If an AI's knowledge is filtered through that weird lens, it restricts its ability to reason effectively in diverse global contexts. It leads to misunderstandings and just plain bad decision-making when you try to apply it universally.
And finally, there's the limit of the medium itself. Our AI is trained on text and 2D images, but the real world is physical. It lacks what people call embodied experience.
This is where we have to stop thinking of AI as just a big calculator. The analogy we often use is riding a bicycle. You can read a million books on how to ride a bike. You can memorize the physics equations, the technique.
You know everything about it in theory.
In theory. But until you actually get on the bike and feel gravity and feel momentum and make those split-second adjustments to balance, you don't actually know how to ride.
So we're building an AI that can pass the written driving test perfectly, but it would slam into a wall the first time it hits a patch of ice.
That is precisely the challenge.
Yeah.
For AI to succeed in robotics and autonomous agents, the future we're all promised,
Yeah.
it needs more than just text and static images. It needs massive amounts of simulation data, 3D video, haptic feedback, data that mimics physics and proprioception, that sense of your own body in space.
So the data crisis isn't just about running out of text.
No, it's about not having the right kind of physical sensory data to let AI actually interact with the 3D world. So when you put this all together, the token crisis, the astronomical cleaning costs, the conceptual limits of the data, the takeaway is pretty clear. The big data era of just vacuuming up the internet is ending. The next frontier isn't about more data, it's about smart data.
Which means the entire industry has to pivot, and pretty aggressively, in 3 critical ways to get past this real data dilemma.
The first is a huge reliance on synthetic data. Instead of just scraping the web, companies will start using their best models to generate high-quality, complex reasoning paths, mathematical proofs, and varied scenarios for other models to learn from. That directly tackles the scarcity problem.
And second, data curation has to become a real art form, not just an afterthought.
Exactly. It's about prioritizing density and quality, the signal over just the sheer volume of tokens. It's about finding the highest value data no matter how small the data set is.
And the final piece.
Multimodal integration. We absolutely have to move beyond text to include the full spectrum of sensory, video, and physical data if we ever want to get to true general-purpose intelligence that can operate in the real world.
So the companies that win this next wave, they won't just be the ones with the biggest server farms. They'll be the ones with the most sophisticated understanding of what it means to truly teach a machine. And for you, the listener, the challenge is this. The next time you use an AI tool, ask yourself a simple question. The question for the next decade isn't just what the AI knows, but whose worldview does it embody? The real deep dive starts when you ask, is this intelligence reflecting my world, or is it fundamentally restricted by the biases of the weird world of its creators?